Hi everybody. What we're going to cover in this video is a complete example of mediation, traditional Barron and Kenny mediation using JASP and Excel. So just a quick rundown of how mediation works. It's an extension of regular multiple regression that has some very specific sort of direction questions. So I've got these pulled from Kenny's website, which you can find if you follow this link, or just Google Mediation Kenny, and you'll find lots and lots of information about where the sort of state of mediation is. But we're going to do the simple version just to show you how it works. So the way that mediation works is that first you need to show that your X variable predicts Y. And we consider that the C path here. So your X variable predicts Y, because the whole point of mediation is to show that this relationship between X and Y is somehow changed with a mediator in the equation, or M. And so if X doesn't predict Y, it's sort of hard to change that relationship because there is no relationship. So X should predict Y first. Okay? And we'll do that by running, it's actually a simple correlation, but a simple regression to get the B value from X to Y. The next step that we'll try is show that the X is related to the mediator. So you got to think about this analysis as sort of the third wheel analysis versus moderation, which is about interactions and regression. And so we have to show that X knows Y, but also knows the third wheel. So X should predict M. And so what we're trying to see really is if the path from X to Y can be redirected through M. And it's sort of like a traffic circle in a sense, where I could go from X to Y directly, but they've got that blocked off because of construction, so now I need to go through M instead. And so X needs to predict M, that's considered the A path, and it should also be significant. The last regression that you run is a regression with both X and M in the equation. Given this picture, it sort of looks like M should predict Y just sort of separately, but really what happens is we throw both of them into a simultaneous multiple regression, and we see what happens. So M should predict Y, showing that our redirection of traffic is complete, so that M goes to Y. But also, that's controlling for X. So we've had X predicts Y and X predicts M. Now I should show that M predicts Y with X in the equation, so controlling for X, and that X to Y is lessened somehow. Traditional mediation, when this first came out, showed that the C prime path should be non-significant. But now we've sort of lessened that idea as that C prime and C, remember C here is without M, C prime is with M, should be different from each other. And the way we can tell if C and C prime are different from each other is called the Sobel Test. So we'll see as we go through here how we test each path and how to do a quick and easy Sobel test online. So I took this example, and it actually was an example from a book, maybe even Hayes' book about mediation and moderation, and just restructured it to be about baseball because it's baseball season. So what we've got is an IV that's either one of the baseball groups, the American League and the National League. Our mediator is our budget money for pitching, and the dependent variable is extra innings of pitching relief. So we've got it's kind of a silly example, but it'll show you how mediation works. And we're going to see if first that IV predicts that DV. So does the baseball group, and we're going to use a categorical variable to make this a little harder, predict our dependent variable. And then we'll see if our independent variable predicts our mediator. And then we'll see if those two together, if the mediator predicts our dependent variable, and if the IV and DV's relationship has now changed. So essentially by IV, I mean this is X, our mediator is M, and our DV here is Y. So does that budget for pitchers mediate the relationship between league and their need for relief innings? Now, power in this case is always a little bit of a tricky subject. There are lots of different ideas about how to calculate power for this, and there are some online calculators, and there's some for R, and they get really confusing. So to just kind of make this simple in G power, what we're going to do is really predict sort of M to Y, because we want X to predict Y originally, and then X to predict M, and then M to predict Y, but X to Y should stop. And so it's sort of a weird situation when you're trying to predict that the relationship goes away. And really the relationship is not going away, it's switching to M. And so what we're going to do is kind of look at like M to Y. And so we can estimate the effect size that we'd expect, so from X to Y, or X to M, or M to Y, the three paths we want to be significant. And we'll pick kind of sort of the lowest one. And so we're going to use, very similar to our moderation video, t-test, right? And then the fixed model single regression coefficient one. So linear multiple regression, fixed model single regression coefficient, because we're only interested in one of those coefficients. Two tails. And then we'll pick which effect size we think is the smallest. And so we'll pick the smallest effect size, so either X to Y, X to M, or M to Y. Right now I'm going to pick M to Y, and I'm going to say it's a medium effect size, just for this example. So I'm going to click Direct, and then 0.09. So calculate and transfer to main over here. Alpha is 0.05, power is 0.8. Since I'm doing M to Y, predictors is 2. That gives me a sample size of 82 participants. And so that's what you'll see here in this picture. But essentially I did M to Y, and I'm going to use 2 predictors because I also have X involved there. If I'm doing either one of these other two, it's only one predictor. And so I kind of have used that as a way to pick the lowest effect size that I'd expect, minus the one I don't expect to be significant. All right. So before we hop into the actual analysis, we're going to do data screening. So let's open that data set. Now, one thing about JASP is that in regression, it will not let you use categorical predictors. So we're going to have to change that. So I'm going to save this as my data screening file. So I'm going to save it as a full Excel workbook so that I can edit the tabs. Here's going to be my master data set. And I learned this one the hard way because I told students that they should code their categorical variables, and then in regression they were like, that doesn't work. So first thing we're going to do is we're going to change our categorical variable here to a continuous or fake dummy coded variable. So we'll pick the American League to be our 0 group. If you aren't sure how to order that, it should be whoever you expect to be the control group to be 0. Or if you don't really have one in particular, especially in only 2 groups, just make them alphabetical order, because then you can remember you did it in alphabetical order. And that just is an easy cheat. So we're going to change everything. It's AL to 0. And then NL to 1. Oops. Place off. And then just, if you want to, you can leave yourself a note. If you're doing real research, I always recommend taking notes on what you're doing as you go, because, 6 months from now, when you get that review back, if you're lucky it's 6 months, you're not going to remember what you did. Guilty as charged. So here's our no typo sheet. Now let's just look here. And like I said, this is totally an example that I took an old example and just made up a baseball theme for. So we want to check our descriptives with the caveat that they're probably not perfect, especially because we obviously do not have 110 teams or 109 teams, but we're talking about multiple innings here, so or multiple years maybe. So just trying to make the example a little more fun. So let's check to make sure our data is accurate. So click Data Analysis, Descriptives. Okay, I'm going to highlight these 2 columns. Labels in the first row, Summary Statistics. And let's look at what we've got here. So for innings, 0 to 30, and that seems like kind of a lot for innings, right? But that might be the pitcher across, you know, a month of games or something. So this is why I said it doesn't totally work, but maybe 30 might have been wrong, so we should fix that. But we'll just pretend that it's accurate. And then their budget from 0 to 20. Okay, we'd have to remember how that was coded. But so assume that data is accurate, but if I were looking at this really, I'd be like, 30 innings, that's not how baseball works. Okay. So we're going to take our no typos data, pretending that it's accurate, and look at missing data. No miss here. Be consistent. And it was pretty clear. I can just kind of scroll through it and see I don't have any missing data, but remember that you can do that %complete function. So equals count A, highlight all 3, close parentheses, if I can find it on my keyboard, divided by 3 here, times 100. And I went from white plus to black plus, and I double clicked, and I have all of my data. If I wanted to do that by column instead, I would do count A, highlight everything, divide by 109 participants or 109 team-year combinations, times 100 to get that %. And I'm doing good here too because I have all of my data across and down. So no missing data. Okay. So we've done accuracy, missing. Let's talk about outliers. Okay, or no out, if I'm consistent with my own videos here. So I can't really have an outlier in the league variable because it's categorical. But I can check my mediator and my y variable here. So we'll do z for innings and z for budget and see what we get here. So open parentheses, equals, open parentheses, sorry. Click on the first data point, minus the word average, open parentheses, click on the whole column, close, close, divided by STDEV, open parentheses, click on the whole column, close, and then hit enter. Remember, you can drag and drop this, so white plus to black plus, drag, and double click. And that shows us that we probably don't have any outliers, but let us highlight in case we do. So highlight both of these columns, click on Home, Conditional Formatting, highlight cell rules, greater than, and let's do 2.99. Do that same thing, conditional formatting, highlight cell rules, less than, negative 2.99. Well, let's see if anything came up. We got one that's close. Saw that one pop up. So one outlier here on the top end of the budget. One that's close here. So it looks like the top end of our budget variable is giving us the high scores, but no particular team combination is giving 2 outliers. Since they're only an outlier 1, I'd probably leave it alone. I'd also check and make sure I had the data correct. So this is going to be our final data set. And what we're going to check, we're not really going to check for additivity. And here's why. The whole point of this analysis is sort of additivity. So I want X and M to be correlated because I want X to predict M. And normally we're concerned about the correlation between predictors. So I want my predictors to be correlated. That's the whole point of at least step 2. So additivity here is that I don't want it to be so correlated the math won't run, but it's not really an assumption I need to check. And so as long as it runs, we're going to be okay. So I'm going to copy this data and save that as a CSV. And really the only difference here is that I changed it from AL and NL to 0 and 1. Now, I'm not really done with data screening, so we're going to do data screening. Oh, hopefully that's saved. My Excel's being weird lately. Let's see here. Make sure we still have all of our tabs. Oh, it didn't save that final tab thing, I don't think. That's okay. We still have everything we need. We're not done with data screening, but a lot of the data screening we can do very easily in JASP, so I'm going to do that. If you want to do it in Excel, like I've shown you in the other videos, you can, but you should check X and M predicting Y together, because that's what we're about to do in JASP. So let us close GPower here, get rid of all these windows, and work on data screening. So I'm going to open my file. Which should be our data 6 final here. So it's dummy coded so I can use it. I'm going to click on regression and linear regression. And then we'll come back over here. We'll talk about what are our predictors and stuff here. So baseball group and budget money are X and M, and pitching relief or innings is our dependent variable. I'm going to take both of these and put them in as covariates. That's not step 1, that's actually step 3 and 4, but I want to look at data screening first. So for data screening, I need to screen both variables together. So what I want to do is click assumption checks down here. Let's do normality first. So residuals histogram and standardized residuals. And it's a little not normal. There shouldn't be, it's kind of bimodal here. I have at least 100 people, so I can be, or I'm sorry, well, I do have 100 people, but I have at least 30 people, so it should be okay. And that might be because the league variable is dichotomous, but it appears that budget is a little bimodal as well. Okay. So this is not super normal, and it's not the greatest. The QQ plot is the same thing as a PP plot. Will give us linearity. It's all right. That little weird stair step there is not great either. So maybe some slight problems with linearity. And the residuals versus predicted, oh goodness, that's not a good picture. So we're not doing so hot right now. The spread is pretty even from 0 to 2, and this way the spread is kind of okay, but clearly for homoscedasticity issues, this is not a pretty picture. Let's see if it's this categorical variable. So I'm going to kind of pop that out. Nope. So sometimes categorical variables will cause you to get some bad residual pictures because they can be either this or that. But clearly in this case, it's actually budget that's causing quite the problem. So see, when you see this, that's because it's a categorical variable. It's either this or that. So you see, the nice thing about JASP is it allows me to kind of play with them and see maybe which one it is, but it's actually both of them that are slightly problematic. So I would say that this analysis is like, it's a technical term, right? It is not quite normal, and we have enough people to kind of get away with that, but heteroscedasticity is going to clearly be an issue. All right. So data screening aside here, I'm going to remove all my analyses just so I don't get confused. But we're going to start by, let's say we get through all that data screening, and we decide to power through a normal analysis. We're going to look at, is X predicting Y? So this is the C path. Okay. And we're going to see if that is significant. So click regression, linear regression. And X here is our league variable. So we just want to know if league predicts innings. And I'm going to turn all this off. I forgot it stayed on. Under statistics, I'm going to get R squared change. That makes life a little easier. We can get part and partials because we've been doing that all year. But when you only have one variable, R squared and part and partials are the same thing. So not totally useful right now, but we can go ahead and click on it. And this is the first thing we want to look at. Because this set of analyses is mostly one variable at a time, people often only report the t-values. Because as you see here in this p-value and here in this p-value, they're the same. So you have one variable, the f statistic and the t statistic agree because they are just squared transforms of each other. But some people will report both. So we'll just kind of go ahead and report both, because then if you have too much information, you can just remove it versus not having enough and you look like a fool because you don't have everything you're supposed to have. So I'd say f of 1 and 107 is 7.03. Our p-value is 0.01 if we round up. Our squared statistic and all the funky fonts is 0.06. So that is significant. And we could talk about the B value for league, which in this case is this C path. So it's still the B value because this is regression and it's a slope, but it's considered the C pathway. I know it's a little confusing, but it's the C path, but the statistic name is a B for slope. Its p-value will also be the same, since I only have one predictor, and if I squared this partial correlation, I would get 0.06. So PR and R here are actually the same, because I only have one predictor. Okay. And it actually is the same thing as our correlation as well. So with 1x and 1y, R, PR, SR, and R are all the same thing. But I can report both just to make people happy. Now, what does this mean? This is a categorical predictor. So dummy coding we talked about a little while ago, but like, what does it mean when there is a categorical predictor here? So I have to remember who's the zero group. Okay, so we made the AL league the zero group. And the slope is negative, so it's going down. So that means the AL is spending, our Y variable here, don't let me say the wrong thing, is extra relief. So our AL group has more extra innings of relief needed. But that can be kind of confusing. So the easiest thing to do is to cheat and get descriptives for each group. So this is really not an ANOVA. You wouldn't actually run this as an ANOVA, so don't do an ANOVA. But if you're using JASP, this is the sort of quick and dirty way to get, sorry, click the right buttons here. Descriptives by groups. So if the JASP people are out there, descriptives by groups in the descriptives window is kind of a necessity. So get on that. But our zero group has more innings needed than our one group, which is AL to NL. So more innings. So why is that slope negative? Well, the slope is negative because it's going down from 0 to 1. Right? So our interpretation here is the AL has more innings pitching relief than NL. Okay. Now, we satisfied step 1 where X predicts Y. Let's look now at X predicting M. And to do that, we just run another regression. And we're just going to switch out our dependent variables. So we need X now to predict M. Let me copy that. I'm going to use this here, just so I don't have to reinvent the APA wheel. So our F statistic here is 1 and 107. It's 6.33, and our p-value is 0.01, so it's significant. R squared for this analysis is 0.06 as well. We will round up. And then our B value is negative 0.83. So again, it's negative. P-value is 0.01. PR squared is going to be 0.24 squared, so 0.06. So what does this statistic mean? Again, I'm going to cheat just real quick, run that ANOVA, switch out our DVs here, just so I can see what's happening. So the AL League has more budget. So they have more pitching innings needed and a higher budget. So $4.5 million or whatever to 2.69. Okay. Oh, AL League is a bit repetitive. AL is a higher budget than the NL. Okay. So we've satisfied the second criteria, where X predicts M. That's considered the A path. So we've found the C path and the A path. Now let's work on B and C prime. It is one regression with two questions. So the first question, does M predict Y with X in the equation? That is the B path. And then as long as that's significant, does X lessen or no longer predict Y with M in the equation? That's C prime. So one more regression, you have to do 3 of them. I'm going to switch out my M variable and move it over to being a predictor. And make innings my dependent variable again. So kind of moving around what the dependent variable is. I might copy that. So step 3 here has one F statistic. And so our F statistic, I'm going to come up here, is 2 and 1 of 6 is 15 effectively. It is significant, so it's less than 0.001. And R squared, both of those variables together is 2, predicting Y. Now let's look at the B value. So we're going to need 2 of these. For league, let's not do league first. I'm sorry, let's do budget first. That's M predicting Y, which is the B path. Not to be confused with B as in the slope of label. So budget predicting Y here, this one, is 1.40. It is significant. I'm going to take 0.41 and square that. Okay, it's 0.17, so I took partial here and squared that. So yes, our mediator predicts Y. That was the third criteria that we have. So the C path is significant, X predicts Y. The A path is significant, X predicts M. The B path is significant, M predicts Y. Now what we're looking for is league here, or X predicting Y, with M, which is the C prime path. That's -4. So the number has gone down from our -6 earlier. It is no longer significant, so P equals 0.09 if we round up. If I can find the 9 on my keyboard. Been that kind of day. 0.16 squared is 0.03. And so what we see, because this is a made-up example, is that when I add budget into the equation, league no longer predicts any pitching relief need. And so what's happening is that league predicts the budget that I have for the pitching, which then predicts the number of innings that relief pitching happens. And so instead of it just being league predicts the number of inning relief pitches, it's that league predicts budget, and budget predicts the number of pitchers that you are allowed to sort of cycle through, or and have more pitching relief innings because you can move through pitchers faster. Now, it's no longer significant, which sort of satisfies the criteria of the Barron and Kinney steps. But if we want to show that C and C prime are significantly different from each other, we can use the Sobel test. So the Sobel test is sort of an addition to the traditional steps from Barron and Kinney, where we can tell if C and C prime are different. So I could find that X predicts M predicts Y, but C and C prime aren't totally changed, which implies that there are a lot of correlated variables and maybe no mediation. So we're really trying to show that there was a redirection of traffic here. And sometimes you want C to be closer to 0. If C prime has actually gotten further away from 0, something else is going on. It might be an interactive effect, which implies moderation instead of mediation. It might be what's called suppression effects. And that suppression is, I think, a little more common if C is positive and C prime is negative, or the reverse. So sometimes you'll get C and C prime are different, but that's because that C prime got much larger. And that is not usually considered mediation. That's something else is going on. With C prime, you want to be closer to 0. So we're going to try our Sobel test to show that our steps were met. And the quick and easy way to do that is to use Chris Preacher's website, which is QuantSci. And we can scroll through all this stuff, and he talks about what's going on. And so the easiest thing to do is to enter T of A and T of B, but you could also do A and B in their standard standard errors from the output, but I find using the T values the easiest because we've already written them all down. And so we want T of the A path and T of the B path. And that's confusing to people because I'm testing if C and C prime are different, but I'm entering the numbers for A and B paths. But that's the way it works. So we're going to go back up here and find our A path. So A path is step 1 here. That's the C path. We want X to predict M, so here's our A path. And our T statistic, which I didn't write down for some reason here, is 2.517. So we'll fix that in just a minute. That's my fault. And then we're going to get the B path here, which is this 4.65. Joink. Calculate. I'm going to take a quick picture of this and stick it in the notes for you guys to see it. Okay. And so we entered T for our A path and T for our B path. It told us the Sobel test is 2.12, and that p-value means it's significant. The Sobel test is a z-test. I managed to cut my finger, and typing with Band-Aid on your finger is a little weird. So, not that I don't normally miss the keys as well. 2.12, our p-value is 0.03. So I would say that C and C prime are significantly different. So all that together is mediation, from kind of power and data screening through running the steps. And the only thing I'd want to fix is actually reporting the stupid t values, because you should. And so I would add those here. So I guess the brief reminder here is that the degrees of freedom is the second degree of freedom. Remember from our F statistic, in this case it's negative 2.65. And I would just add those. So 2.52. Because it's always, oh gosh, Word, thank you for helping me by de-italicizing. It's negative 2.52. Okay, from here, it always helps to have more information rather than less. Now, how would I report all of these values? And this time it's 106, right? Because our degrees of freedom goes down 1. And what I've traditionally done is stuck the F statistics in a table and just reported the B statistics in the write-up. because I sort of usually less interested in the F statistics. And so you'll see that in the example right up here, which is much more boring about housing, I think. And I've got the T statistics here, which should include PR square, which I'll add here in a second. And then the F statistics are here on this table. And then the coefficients, the B coefficients, are actually here in this cute little diagram. And don't recreate the wheel. Copy my diagram and edit it. So this was the original example that is definitely from Hayes's book. Okay. So all that is very simple mediation.